Our next topic is infinite geometric series. If you look at the index for the infinite geometric series, we're starting out at 1 and we're working our way up to infinity. So what that means is that we're adding up an infinite amount of terms. That's kind of an interesting concept, and we're only talking about it very briefly here. If you take Calc 2, they talk about it way more in depth. So there's two possible outcomes for an infinite geometric series. It can either converge or diverge. If it converges, that means it's converging to a specific value. So even though you're adding up an infinite amount of terms, it's still going to just a specific value. This is kind of a similar concept to an asymptote. So if you have like a graph with an asymptote and you're going as far as you can to the right, so even though you're going to infinity, it could be approaching an asymptote, which means it's approaching that specific value. So it's a similar concept here. And this will happen when r is between -1 and 1. So if it's like a decimal or a fraction. Now, the other possibility is that the series diverges. And that means that the series is going to go to infinity or negative infinity. And this will happen when r is greater than or equal to 1 or less than or equal to -1. So the proof for convergence, we start with the geometric series formula. And if you take n going to infinity, then r to the n, which is right here, is going to go to 0. And that'll really happen with any fraction. So again, r is a fraction here. So for example, if you take 1/2 on your calculator and raise it to a really high power like 10,000, you can see that it's going to 0. So 1 minus 0 is just 1, and then a1 times 1 is just a1. So the numerator will just be a1, and you'll get the formula for the value that our series is converging to. For the divergence, there's a couple cases. If r is greater than 1, each term that you add will be larger and larger. Therefore, the series value will go to positive or negative infinity. If r is equal to 1, each term that you add is the same. However, the series value will continue to increase. It's going to increase slowly, but it'll still increase to either infinity or negative infinity. And then lastly, if r is equal to -1, the sum of the terms will alternate between two values. Now this is a different type of divergence, but it still diverges. Okay, so looking at number 14, it says determine if the infinite geometric series are convergent or divergent. And if it's convergent, find the sum of the series. So my r value here is 0.75. And that is between -1 and 1. So this is convergent. So I want to find the value that this series converges to. So if you take a1, which is 3, and r, which is 0.75, and put those in your formula, it's going to be 3 over 1 minus 0.75, which is equal to 12. So this is the value that the series will be equal to. So the sum will equal 12. A way to check this is if you just add up like maybe the first 20 terms of this series, it should be a value that's pretty close to 12. So if you just plug in 1, plug in 2, plug in 3, plug in 4, and then add up the first 20 terms of this series, then it should be a number pretty close to 12. So if you want to check your work, you can do that. On number 15, r is equal to 5.63, and that is larger than 1. So this series is going to diverge. So it's a divergent series. On 16, r is equal to 0.25, and 0.25 is between -1 and 1, so this is convergent. And A1 is 6, R is 0.25, so if we plug those into our formula, we find that the series converges to the value 8.